In this lesson, we're going to talk about one of the most important ideas in geometry. In fact, one of the most important ideas in mathematics in general, the Pythagorean Theorem. Now, don't let the name scare you. It's called Pythagorean because it's named after some guy from ancient Greece named Pythagoras. Now, it's not really fair that he gets credit for this because the Pythagorean Theorem was discovered by all sorts of different civilizations all over the world centuries before Pythagoras was even born. But it's the name we're stuck with, so that's what we're going to go with here. Also, this video isn't going to explain why this rule is true. There are literally thousands of videos on YouTube that will go into that. In fact, if I remember, I'll find another video from someone else that I can link in the description of this video that'll describe why the rule's true. For this video, we're just going to look at what the rule actually says and start looking at what we can do with it. So, firstly, some definitions. Now, you may know some of these, but others will be less familiar. So, firstly, a right angle is an angle which measures 90 degrees. A right triangle, as the name suggests, is a triangle with a right angle. So the diagram that we have here is a right triangle because this here is our right angle. And you may be able to recall that this little square symbol in the corner of an angle means it's a right angle. Now, the longest side of a right triangle has a particular name, and that is the hypotenuse. So in this case, the hypotenuse is this side here. This is our longest side. So I'm going to label that as hypotenuse. Now the other two sides we're going to call legs. So here I have a leg and then I have my other leg. Now notice in this case that the legs are the ones next to or attached to our right angle. Now in geometry, we use a particular word to describe this. We say they are adjacent to the right angle, which means they touch it. Adjacent literally means next to. Which side is not adjacent to our right angle? Well, that longest side, which we called the hypotenuse. So, from these definitions, we're now going to write what the actual rule is, the Pythagorean Theorem. So we have a triangle with three sides, as all triangles do, but we're going to label the lengths of the sides as A, B, and C, where C is the longest side. Notice I haven't said that C is a hypotenuse yet because we don't know if it's a right triangle. Only a right triangle actually has a hypotenuse. Well, we're going to say that this triangle is a right triangle as long as this condition is true. If you square the two legs, A and B, and add them together, you get the same thing as the hypotenuse squared. Or we could more simply read the equation. A squared plus B squared equals C squared. So that means that in a right triangle, A and B are the lengths of the legs, and C is the length of the hypotenuse. Now, as we go through and do problems involving right triangles, if we're wanting to make use of the Pythagorean theorem, it's a good idea to know which side is which ones are the legs and which one's the hypotenuse. So to keep that straight, we're going to always label the sides A, B, and C when working with our right triangles. So there are many things you can do with the Pythagorean theorem, and in this course we're only going to scratch the surface. But today we're going to start with one example of what we can do. We can work out whether a triangle is a right triangle or not. So you might look at these triangles and think, well, these certainly look like they're right angles. But remember, in math, a diagram can only give us the information we're explicitly told. There's no little square symbol in the corners here, so we can't know for certain that these are actually right angles. Well, at least we can't unless we do a little bit of work and apply the Pythagorean theorem to show that that really is true. So let's look at the first triangle here. I have three sides. I need to label them A, B, and C. Now, if C really is a hypotenuse, it needs to be the longest one. So I'm going to label this side, the 26 inches, as C. That leaves my other two sides as A and B. Now, it doesn't matter which one's which, as long as they're each labelled as our two legs, A and B. So, what does the Pythagorean theorem say? Well, it's a right triangle if and only if this equation is true. How do we check that that equation is true? Well, we're going to work out what a squared plus b squared is equal to. And then we're going to work out what c squared is equal to. And if those are the same, then the equation is true. So, a squared plus b squared will equal 10 squared plus 24 squared. Now, feel free to use a calculator to help you out with this, but 10 squared happens to be 100, and 24 squared happens to be 576. Add those together, we get 676. Okay. The other side of our equation for the Pythagorean theorem is c squared. So c squared, we know that c is 26, so this will be 26 squared, which is 676. Well, would you look at that? Our two values are the same. Well, if these are the same, it means that this expression, a squared plus b squared, is the same as c squared. So, a squared plus b squared equals c squared. But the Pythagorean theorem tells us this is only true if this is a right triangle. Therefore, it is. This is a right triangle. And I'm going to go ahead and label the angle between my two legs as a right angle. Let's look at the next example. So we've got three sides, 15, 15, and 21. We know C has to be the longest one. A and B, doesn't matter which one is which. Really doesn't matter in this case because they're both 15. But let's go through the same process as before. So we need to know what A squared plus B squared is. So this will be 15 squared plus 15 squared. 15 squared is 225. And 225 plus 225 is 450. Now, C squared is 21 squared. And 21 squared is equal to 441. We look at these two values, these are not the same, which means these expressions, a squared plus b squared and c squared, are not the same. Now remember, the only way for this to be a right triangle is if these two expressions are equal, but we've just found they're not. That means, no matter what we do, this is not a right triangle. So even though you might look at the diagram and go, that certainly looks like it's a right angle, it's actually not. And keep in mind, this was really close to being a right triangle. These numbers are really close together. If c squared was a little bit bigger, which would just mean that C was a little bit bigger, this would be a right triangle. But it's not. Let's look at the third example. So, 3 sides again. C is always the longest one. In this case, that's the one that is 13 feet. Our other 2 sides, it doesn't matter how we label them. So I'm going to go with this choice. Those are our 2 legs. So, hopefully you're getting used to the process now. First, we need to find a squared plus b squared. This will be 7 squared plus 11 squared, which will be 49 plus 121, which is 170. C squared will be 13 squared, which is 169. Now this was so close to being a right triangle because these numbers are really close together, but they're not. So because these 2 numbers are different, it means that c squared and a squared plus b squared are different. Let's actually write that out explicitly. So a squared plus b squared does not equal c squared. Therefore, this is not a right triangle. And there you have it, using the Pythagorean theorem to work out if we really have a right triangle or not. Now keep in mind, this is just the first way we're using the Pythagorean theorem. As we're going to discover through the rest of this unit, there are a whole lot of other ways and a whole lot of other problems that the Pythagorean theorem can be used to solve.